Welcome to Spirit Behind the Screen. Each episode, your host, Marty McCurdy, deep dives on industry trends around high reliability electronics and the supply chain in aerospace and defense. This is episode 66 with Rajan Rajgopal, CEO of Zero Error Systems, on radiation protection for space applications.
Good afternoon. This is Marty McCurdy with Behind the Screen at Spirit Electronics. And today we have ZES with us and CEO Rajan Rajgopal. Well, thank you for joining us today. I think that I'm super excited to talk about what ZES is doing in the marketplace because you really are coming in as a disruptor. And I had the pleasure of giving a paper on ZES at one of the conferences recently in RET in Huntsville, Alabama. So I know that my reaction, the people that were attending, the reaction there was, hey, what's going on here? This is something exciting. So you must be excited every day about what's happening in the industry as you see it. So why don't you give us just an overview of what ZES is doing to disrupt the industry in like the COTS flying in space from a radiation standpoint?
Thanks, Marty, for having me. Zero Error Systems, or ZES, really started with some original research maybe about 10 years back in a university here in Singapore called NTU. So the founders were doing their PhDs under Professor Chang, and the three of them decided to spin off a company based on the original research that they did on hardware reliability and data integrity, really focused on radiation effects on electronics. So as everybody knows, there's radiation in space, and then there's radiation on Earth. So pretty much it can impact electronics anywhere that we know. And what are those impacts? So you can have hardware damage as a result of radiation, or you can have kind of a soft error type of damage, which results in bit flipping of your electronics or your memory. These two impacts have got obviously consequences. You can lose your space assets. There's in-car safety, particularly when cars become level 4, level 5 automation. Bit flipping or data integrity becomes a major issue. Satellites in communication can have service interruptions, and then incorrect computation, as a result of the electronics not working like the way they should. So that was the original research that really started the Zero Error Systems journey, which was founded in 2019 and has continued to develop solutions over these last 5 years. Specifically, we have 27 patents that we have built our products around. Our solutions include semiconductor components. We have IP design services that we offer, including licensing of our library cells. We have laser test advisory services. So if someone wants their COTS component laser tested, we can certainly provide that. And then we also combine our products into providing a system solution called a ZSOM, or a system on module. So these are our solutions, and essentially all of them focus around providing radiation protection to pretty much any COTS component. Mm-hmm. And that's where the real fundamental of the IP is how we protect regular commercially off-the-shelf available semiconductor devices against radiation damage. Right. And as a result of that, our focus is really in the space, 5G IoT areas, as well as automotive.
Yeah, that is what I call the disruptor, right? So yep. You have a lot of customers out there that are buying, rad hard by design, rad hard by process, space grade products. And I think we had this discussion, you and I, it isn't to displace these. It really is about adding that insurance layer, right? So I think one of the very interesting things about how ZES is approaching this, for example, let's talk a little bit about the micro-SELs, right? So most companies, when there is a radiation upset, they are waiting till it's, I won't call it catastrophic, but it's a failure. But your ability in how you're approaching the solution is you're really starting to catch the radiation effects earlier, and that is in the micro-SELs. So if we could touch on that to kind of give a little bit of the technology behind, even though you do have a rad hard product, let's, call it the Xilinx Versal or what, TIs, ADCs and DACs, that kind of thing. It isn't to now buy COTS and buy a cheaper product. This is for everybody on the market, right? It's the low end folks chucking up the CubeSats. It's the the big birds that the government's throwing up. But this is very, very affordable insurance, so that the industry can give that one extra tap of protection against these things, and also earlier detection.
Yeah, so Marty, the way we do our radiation protection is we protect the power line against single event latchup. We have a product that is known as the Latchup Detection and Protection IC, or LDAP. So this LDAP essentially has got algorithms that are able to detect what are called micro-SELs. So think of micro-SELs as a cumulative effect that eventually produce a SEL, or a single event latchup. Typical solutions in the market, like a latchup current limiter, these are the ones that are typically used. They protect against SELs or overcurrent actually at the bus level. What we have done is we have now taken that one step further, where we've now got a chip that connects to every power line that goes into any COTS component, be it an ADC, be it a microcontroller, be it a GPU, CPU, FPGA, any power line. We put our LDAP in front of it. What it does is it detects every time there is what is called a single event latchup event. Specifically, it is called a micro latchup, where the current accumulation that always takes place at a very small amounts of current at a time, and we call these micro-SELs. Actually, this was a phrase that was coined by NASA almost like 15, 20 years back to figure out the whole latch-up mechanism. It's actually accumulation of current, and they call this a micro latch-up. So every time there is an event, a micro latch-up occurs, the current values increase in your CMOS transistor. And what our circuit is able to do is truly detect this micro SEL, and it gives the user the ability to reset the COTS component before it actually gets to the threshold current level, where, as you know, once it gets to this threshold current level, the chip can get shorted and not work.
Right.
So this is a true protection against radiation damage that causes single event latchups.
On the micro SELs, let's just talk about how the current industry is insufficient in detecting those, right? So basically there's several micro SELs that occur, let's say 6 to 8 over time as the current is building. And most insufficiencies in detecting that today you have overcome. So you can actually see the first micro SEL where most people are maybe 7 or 8 micro SELs into the process of damaging the component while it's in orbit. There's no recapturing it, right? It's already flying. So that I think is, the advanced look, if you will.
Yeah, absolutely. I mean, in fact, if you wait for 7, 8 micro SELs, say in an ADC, you could pretty much short circuit the ADC and the ADC is dead. And then we've actually demonstrated that phenomena where we did some experiments where we connected a standard LCL chip to an ADC. and then connected, and then in our experiment, we connected an LDAP to an ADC, and we actually measured micro SELs and SELs on Earth, doing a heavy ion experiment at TAMU, as well as then took that same circuit into space and put it up on a satellite, BIRDS 4 satellite under Kyushu Institute of Technology. This was way back in 2021. It was a one-year flight mission of a CubeSat, and clearly the current solution, which was the LCL connected to an ADC, did not detect any micro SEL, did not detect any SELs in 1 year. Whereas our solution actually detected 41 micro SELs. Of course, it did not detect SELs because we were able to prevent it. But the fact that in space, within a span of 1 year, it detected 41 micro SELs is really a testament to our LDAP chip's ability to really pick up this micro SEL and then be able to shut the COTS component down or reset it in the event that we do not allow it to reach that 7, 8, 10 micro SELs that could potentially destroy the chip. And as you put it, this is clearly an insurance for any COTS components.
Right. Yes, I've used the insurance analogy the majority of my life for screen and qual. Somebody comes in and you want you to barely touch it, and then they go, well, what else should we do? Well, it's insurance, and I think what was so funny was when I did the presentation at RET to present the ZES, especially the LDAP, I had the insurance slide in there, and then the next slide was, it's your 16-year-old daughter learning to drive. Which of these two vehicles would you rather her be in for insurance? One was a Ford Pinto and the other one was an Abrams tank. And nobody in the audience got it because then somebody else came up afterwards and they go, that's because the audience they're too young. They don't know what a Ford Pinto is. I'm just like, okay, I blew that one.
That was a good one.
Yeah. So one of the other things, obviously, we do heavy test here at Spirit. And we always call it the walking wounded, right? So somebody goes out and, let's call it reball, but they destroy the pads and the balls of an FPGA, or, there's something occurring, a thermal runaway or whatever, but it's being managed. But there's always what, we deem this damage effect that's happening that's not measurable unless you're on a high-end tester like ours and we can see them. But I think you have even approached that kind of resolution, let's call it, in just looking at temperature alone, right? Everybody knows that temperature is damaging. And the micro SELs are actually not only a current draw, but they also are starting to affect the heat factor of the packaged component. And then once you have multiple micro SELs, now you're quadrupling that temperature range that the part might not be rated for.
That's right. That's right. So one of the obviously the negatives of semiconductor components operating at high temperatures is their lifetime reduces. So when an individual component's lifetime reduces, it basically means that your satellite lifetime is going to degrade as a result of these micro SELs. So again, we did an experiment that we bombarded a particular FPGA without any micro SELs, and we took a picture of its thermal characteristics, and you can see in normal operation, any COTS IC will operate at about 30 degrees centigrade, and then with one micro SEL, that temperature of operation went up to 45 degrees centigrade. You do multiple SELs, suddenly the COTS component is now operating at 150 centigrade. And I think as everybody knows, the majority of COTS components are rated for operation between 0C and 70C. Mm-hmm. Okay, that is how semiconductors are manufactured anywhere in the world. And if left unchecked, these micro SELs will really cluster into degrading the long-term reliability and shortening the lifetime of the COTS IC. And I think that's the real danger that a lot of people don't fully understand, is that that directly leads to a satellite, from a 3 to 5 year lifetime to maybe, a 2 year lifetime or a 1 year lifetime. These I'm talking about CubeSats. So what our LDAP can do is truly increase the lifetime and the operating life of a satellite, and thereby improving the return on investment for whatever service that you are providing using that satellite. And I think that's the real value add that our component brings to the market. And it's truly a unique solution that at least I have not seen this anywhere else.
Yep, I totally agree. That's nobody wants to have payload on there that somebody's paying for, right? And the bird goes south, 2 years into a 5-year mission. Somebody's gonna need a refund.
That's right.
Well, I think always in our industry, as you and I probably know, that space flight heritage is always key, and I'm super thrilled to watch what's happening at ZES because you do have flight heritage, and I believe you have NASA has a launch coming up here. It's either within weeks or in a month. Tell us about that.
Yeah, so far we've had 4 different flight legacies. So 3 of them were with Kyushu Technology, which is, I would say, the premier Japanese institute for space technology. So, and that's the earlier one I talked about, where we had 541 Micro-SEL events. We've also put our payload on Eutelsat or OneWeb. So that's flying right now as we speak, and we're getting data on it on a regular basis. We've got 3 additional missions, of which one of them is the NASA mission, where we actually built a specific payload for NASA. And interestingly enough, and even I was surprised to hear this, was NASA does not have a way to detect micro-SELs. And so we said, hey, we know how to detect micro-SELs. So they said, okay, hey, build us a demo. So we did exactly that. We kind of used the same concept that we had demonstrated with the KIT satellite, where we took a ADC and we connected our LDAP to this A2D controller and started to monitor the micro-SELs, and the data was being captured on our SOM that we have, a system on module that is based on a microcontroller, which is also radiation tolerant because it's protected by our components. So we then mounted this SOM board on top of a carrier board, and we gave this entire demo board to NASA, and NASA has finished all the testing. They are going to fly this particular payload on a education technology satellite. They call it EdTech. So NASA has many EdTechs that they launch, and they're going to launch this in April. The launch got delayed a little bit, but they've told us that they will launch it in April. And I think what's the encouraging part for us is that the team that is evaluating this for us at NASA Ames have also connected with other groups at NASA. And I think if they find success on this particular mission, they have told us that the other teams are also very interested in evaluating this technology.
Yeah, I think it's very exciting. Obviously, launching in December, you always got to watch out for the sleigh, right? So, but I know I did have a list of your 3 launches this year. It's very exciting. But in each of those, like your ZSOM is going up with the Japanese CubeSat, but the NASA, you also have a point of load on that one. And then
That's
later
right.
on with the third one, you actually have quite a variety. You have the LDAP, the point of load, and then you had a voter on there as well, which is, that's tried and true then, right? You have true flight heritage on everything.
That's right. That's right. Yeah, our point of load is on the NASA payload, and so is the voter. So I think that is something that is really going to help us, where all our components are coming together on one payload. So we're excited, for the April launch, and hopefully nothing happens to that launch.
Well, you never know until it's flying, right? I think the one, maybe unsung advantage of your process and your IP being able to provide protection and against radiation is that for those companies out there, let's take I don't want to use NVIDIA because they're always in the news, but somebody simple, right? Like a Lattice or somebody that provides really high quality commercial products that have never been in the space business. And all of a sudden now they kind of can have a piggyback ride with ZES and go, hey, you can design what you want for your payload or your satellite with our components now, because now we can provide that service. I think that's a caveat that might be missed in the conversation, because we don't usually have a very big COTS community looking at us as part of their customer base, right? They look at us and go, oh, we don't play in that space. But now you have opened the door for them to come in and play with the insurance that they need.
Yeah, I think a very important trend that has taken place over the last 5 to 7 years in the satellite business is, of course, this trend of CubeSats, small sats, nanosats, all going up in LEO orbit, right? So they've got a whole bunch of players, frankly, around the world. I mean, what we are seeing is every country in the world is now wanting to put up a constellation of LEO satellites. So what's happening is that the total number of satellite launches have quadrupled over the last 10 years. And what that means is, small players, new players, what we call new space, they all want to launch different applications that, maybe didn't exist 10 years back, but they want to do it with the latest and greatest technology that's available on ground. Everybody wants to use the state-of-the-art FPGA for edge computing. So GPUs are becoming, talked about. Hey, how do I use a GPU for my edge computing application in space or AI applications in space? I want to build a data server in space. How do I do that without a GPU? Similarly, how do I do state-of-the-art communication using a RF SOC, made by Xilinx, which today is not radiation tolerant. So we, using our LDAP protection, our point of load, our water chip protections, those provide any component to be used in space for any application. And I think this is where the real true disruption is taking place. And as you mentioned, players, that, for example, companies like Lattice, as you said, they've never, don't have any flight legacy. And now people can think about, because they may be using a Lattice component on their ground applications. And so they're used to it. I mean, I think people know how difficult it is to master one operation of one semiconductor SoC. And then so people don't want to relearn how an FPGA works or how a CPU or a GPU works. So you can just use that same knowledge and now apply it for space application. And I think we provide that ability. And I think that is truly disruption. And, we have seen now that this message has been now resonating thanks to, frankly, folks like yourself, presenting at RET. As you know, we were at Bremen and in Space Tech just a month back or a few weeks back, and a lot of companies came up to us at our booth and said, hey, we like your technology, and then we want to figure out how to use it. So I think it's gaining a lot of momentum and traction.
Yes, I do too. It's exciting to be on the team with you. And I think, I call you ZES, Zero Arrow Systems. I think you're becoming the big disruptor, right? Like when I get kudos in my emails from the NASA and JPL folks, I'd say that's a win.
That's wonderful to hear.
Exactly. Well, Rajan, I know it's super early in Singapore. I certainly appreciate you being on the show with us today. Is there any closing thoughts that you have? I think we've covered, at least for me, from a kind of a high level view, where the customer can start to evaluate what they're doing, right? Like we didn't talk about annealing or anything like that. I think this prevents all of that, right? We're going to reset the component before it gets into this state that needs an anneal, and maybe the redundancy that's required in some applications, maybe that cuts costs because now redundancy isn't as mandatory, these kinds of things. But I think you're on the right path of, how do we launch quicker, safer, more effectively against radiation for lower cost, right? We have competition out there in the world.
Just a couple of points to close, Marty, is, there are a couple of new products that we are developing. And in fact, we did announce one new product at Space Tech, which was a Latchup current limiter, which is your traditional, LCL that protects components at the bus level. And again, this is more of an overcurrent protection. So we are now providing a solution, which is a radiation hardened chip that also does this overcurrent protection. And then this is a family of products that we would be launching, starting with a 15 volt, followed by a 28, and then finally a 60 volt product. And again, just to be clear, this is a protection against overcurrent, not a protection against SEL. So it's a very different product than our LDAP. But we felt that it was important to provide, again, something in the industry that was not available. For example, this LCL is in a plastic package. It's a rad hard LCL that's in a plastic package. Today, or the LCLs that are radiation hardened are all in ceramic packages, so making them very expensive. So that's one solution that we think is also going to be very critical to bringing the cost down of your overall payload or overall system. The second product, which is a little bit more of an ambitious product for us, is we are now building a system on module using a FPGA, which is, I would say, one of the state-of-the-art FPGAs in the Xilinx family or AMD family. It's a MP-SoC that we are now building. We have actually designed the board, and we are getting ready to launch the product in first quarter of 2025. And this is going to be a complete SOM that can just be plugged into your bus of your CubeSat. We're going to use the PC 104 standard which is a standard for satellite PCBs. And, we're very excited about this product. And really the main disruptor here is, of course, providing a radiation tolerant FPGA that, you can now use in space that previously you could not. And I think as most people know, a rad tolerant FPGA by itself can cost, north of $75,000. What we envision with this new system on module and protection of this FPGA using our components is that the cost of the BOM will be reduced by almost 50%. So not only do you get the higher performing FPGA that you can use, but you also get a reduction in cost. So it's like a double impetus for people to yes. buy the system on module for us. So this product will be launched in Q1 2025, and we expect a very, very big demand for applications like edge computing or SAR applications. So, synthetic aperture radar is becoming huge all around the world. I mean, every government wants to monitor every other government.
Right, exactly.
So I think that's the market that we are targeting for this particular FPGA board.
Yes, you and I thrive when geopolitical issues arise, right? I know for sure that, here at Spirit, we're a U.S. distribution channel for ZES, but one of the ones that's a nemesis to me and has been for years is getting a good DC to DC converter. So on our list, the LDAP obviously is there, the point of load, the voter, which we talked about, and you just mentioned the ZSOM, but the other one is the DC to DC converter, right? Like everybody needs that. And finding a solution there, let's get that to the market.
Yeah, so we've got in the market a 5 volt and a 12 volt DC to DC, of course, not radiation hardened, but just a standard DC to DC. And we've got one that's 5 volts and 12 volts. One of the unique properties that we used to design our point of load is the power efficiency. And we've applied that same IP to developing this commercial version of a DC-DC where the power efficiencies are above 85%, even at low loads. And that's what makes our DC-DC, again, quite unique. We have benched ourselves against the leaders in the market. And we have found that at low loads, and this is what is important for a lot of the applications, particularly battery applications, power efficiencies at the low current values, and how efficiently it does the conversion is very critical. And more importantly, we have the ability and we have an IP that allows us to do what is called a single step down. Today, most of the high voltage DC to DC converters, for example, a 48 volt, has to step down from 48 to 28 to 12 to 5 to get to the semiconductor voltage levels. What our IP does is that we can go directly from 48 to 1 volt. And again, this speaks to the power efficiency capabilities that our product provides. And again, converting that voltage at an efficiency level of over 85%. Again, this does not exist in the market today, and then 48 volt will come out. We will have our first proof of concept by first quarter of next year. And this, if all goes well, we should have this product out in the market sometime in Q3 of 2025. So that's another good point that you brought up, Marty.
Yeah, it's. I think one of the other things we talked about, but is I think that's a great point, right? The step is 1 down to a 1 volt. But I believe, are you in LP as well? Like we can get under 1 volt, or where do you think the cap is on that?
We can go down to 0.8.
Okay.
So we can go down to 0.8 volts. The 1 volt is just an easy number to talk about, but technically our converters can go down to 0.8.
Sounds great. Good.
Yeah.
Well, Rajan, I appreciate you being on the show today. Super information for our listeners out there, right? Again, it's a joy to converse with you over the disruption that may be coming in the marketplace. But in the end, everybody gets a better product, right? Everybody gets more insurance. So, the objective is, we want to make sure that what we're putting up there stays up there. It's functional. Let's, not proliferate Leo with space junk because it quit working, right? So I think it's exciting, and I certainly look forward to 2025 working with ZES. Thank you again, and listeners, we appreciate your time on Spirit's podcast Behind the Screen, and our guests today were ZES and CEO Rajan Rajgopal.
Thanks for listening with Spirit this week. Be sure to subscribe, rate, and review this podcast to let us know what you want to hear about in aerospace and defense. You can find out more about Spirit's value-added services and product lines at spiritelectronics.com.